Hello and welcome to this webinar from Würth Elektronik. My name is Vivian Neuberger and I will moderate this webinar today. Also, I would like to welcome Timur. Hi, Timur.
Hi.
He is product manager for power modules and will do the presentation today and answer your questions afterwards. Our webinar topic today is Mastering Galvanic Isolation, ensuring safety in power electronics with products from Würth Elektronik. To better understand the practical changes involved and the solutions Würth Elektronik offers, I would now like to hand over to Timur, who will guide us step by step through the technical background and applications. Have a nice webinar. Enjoy.
Thank you, Vivian, for your introduction. So, galvanic isolation. Today's webinar covers the basics about galvanic isolation, the standards around, and shows which Würth Elektronik ISOs products are suitable here. After the webinar, you should have all the necessary knowledge you need to build up an application with a galvanic isolation with a Würth Elektronik product. First of all, what actually is a galvanic isolation? Therefore, I ask Copilot and let's check out. So, due to Copilot, a galvanic isolation is a separation of electrical circuits so that no direct current or unintended current can flow between them, even though they may exchange signals or power. Why do I need a galvanic isolation? For safety barrier between hazardous voltages and the users, as obvious. Separation of ground loops between spatial circuits. Minimization of common mode interference. And interference-free data transmission. If we now take the definition we have for a galvanic isolation plus the needs we have for an isolation and put it in one block diagram, then it is more tangible to see what it is all about here with the galvanic isolation. The block diagram here shows the situation of a data transmission system. We have here a device 1, we have got here a device 2, and in the middle here we have got the isolator. The isolator here electrically potentially separates device 1 from device 2 from each other so that they can work separately and therefore there is no interference between them. The data flow here runs via the isolator, but the interference and potential equalization currents are held back from the galvanic isolation. In which applications we have a galvanic isolation? There are, let's say, mainly 3 application blocks, clusters, where you need an isolation. First of all, on the left side here, industrial automation, where we have a large number of interfaces like CAN, SPI, RS-232 and RS-485. The next one here in the middle, these are the applications where you have power supplies and converters. For example, the power supplies, UPSs, solar inverters for telecom or power supplies for lighting. And finally, here on the right side, smart metering solutions and chargers for electrical vehicles. When we're dealing with the subject of a galvanic isolation, there are always buzzwords that crops up here. Let us now dig a little bit deeper in this buzzwords and let me try to explain you what they actually mean. In the following, we provide here let's say, a simplified definition for all the top topics to have a better understanding. We have got standards, types of isolation, clearance and creepage, and distance through isolation. Standards. Let's check out what we have about standards. Broadly speaking, there are three types of standards. We have got the basic safety publications here on the top. Then we have component standards, and we also have here device standards. A basic safety publication here provides, let's say, the fundament of the isolation. That means that all the necessary information about the safety principles and the guidelines over a wide range of applications are here condensed so that you can use it. The purpose here of a basic safety publication is to establish, let's say, a common understanding of what safety requirements are and give therefore a good use for the practical work. Second, the component standards. The component standards are specific to each electronic component, such as we have got resistors, capacitors, inductors, transformers, digital isolators. They have all specific component standards. The third one are device standards. When you speak about a device, then this is more than a component. It is a subassembly. It is, let's say, a small application, or can also be a bigger application. That means it is built of a lot of parts, a lot of components. Then we speak of a device. Second, if we deal with galvanic isolation, is the definition of the types of isolation. I will try here to make it a little bit more easy and not so, let's say, driven by the correct wording of the standard to have a better understanding. First of all, the functional isolation. The functional isolation has no protection against electric shock. Means if you have got a functional isolation, you cannot touch because it has no isolation barrier that has a protection against, let's say, a hazardous voltage. Second, the basic isolation. The basic isolation gives you a first real isolation so that you cannot get an electric shock. The third one and the fourth one are double isolation. The double isolation is the basic isolation plus a second layer of isolation, so that also in a one failure event you will have a good isolation. And a reinforced isolation means you have got a single big block of isolation you cannot destroy, which covers the whole material and is therefore a very robust solution for isolation. Then clearance and creepage. Clearance here is the shortest distance through air between two conductive parts. Means trace 1 and trace 2. It indicates how much electrical potential the air gap can withstand before an electric breakdown causes a discharge. If you have a clearance violation, this can lead to a flashover where the air is ionized and it creates a conductive part between the two traces. The creepage is the shortest path along the surface. That goes here, of an insulating material between two conductive parts. It considers the possibility of surface degradation, contamination, or tracking over time, especially relevant in areas where you have got humidity and dust. And last but not least, distance through isolation. The distance through isolation represents the minimum physical thickness here of an insulation material between two conductive parts. We have got here trace 1 and here trace 2. And the distance through isolation is here, the distance you see here. Now we know why we need a galvanic isolation. We know what a galvanic isolation is, how is it defined, but how can we realize a galvanic isolation? There are multiple ways to achieve galvanic isolation, each with its own trade-offs in terms of, let's say, signal transmission or power transmission. Now I will show you the most common options when implementing galvanic isolation, including optical, where you have got optocouplers, capacitive, where you have got digital isolators or capacitors, and inductive, means you have got an isolated power module or a transformer. For a better understanding now, I will bring now together the ISOs products with which galvanic isolation can be realized. With the different categories of standards you already know, to have here, let's say, a more broader view and to have here also, let's say, a more common understanding. The component standards we have learned are for the components. And here we see we have got here for the optocouplers, the digital isolators, transformers, capacitors, we have here different component standards. If we now go the next step, then we have device standards. There you can see the power modules here are certified under a device standard. So one type, one category of standard is missing. The one that is missing is the basic safety publication. As you can see here, the basic safety publication, the IC 60664-1, is, let's say, the foundation that gives you the information for all component standard and also for the device standard, to have the common understanding of what is a galvanic isolation, how it should be treated, how many millimeters you need for clearance and creepage or for distance through isolation, isolation voltage. All this comes from the basic safety publication, and there's also the need that all component or device standards should be based and refer this basic safety publication, so that the understanding is in each of them equal. Next, what do we have as ISOs to build up a galvanic isolation? First of all, we have here the optocoupler. The operation of an optocoupler begins when an electrical input signal drives the internal LED here. The LED then emits an infrared light here, which is then received by the photodetector we have here, and the other side of the isolation barrier. And you will see then there's a signal here on these two pins. The isolation is realized through this optical gel that is the, let's say, the barrier that holds back the hazardous voltages between the primary side and the secondary side. Where do we use an optocoupler? In most isolated converters that require a tight output voltage regulation, here we use an optocoupler to transfer the feedback signal here from the output voltage divider across the isolation barrier here from the secondary side, from the compensator to the primary side to the controller. That means we have got here a signal isolation from the secondary side to the primary side. Which isolations can I build up with an optocoupler? Due to their design, optocouplers have the following isolation properties. First of all, they have a safety barrier between hazardous voltages and a user. Second, you can make a separation of ground loops between spatial circuits. Third, minimization of common mode interference and interference-free data transmission. I will show now with all the products, I will show you this special slide so that you understand what is possible to do with the products. Next, we have the digital isolator. The digital isolator transmits signals across a capacitive isolation barrier, here and here, by using a modulator that transmits a high frequency signal here over the isolation barrier. The receiver here demodulates the high frequency signal into an output signal that you can see here on out A and out B. The isolation barrier here of the capacitor is a special material that you use in a CMOS building process. Where do we use a digital isolator? Digital isolators are often used to isolate communication buses, such as an SPI interface. Means you have got here an ADC. You measure here at the place where you have got a dangerous voltage. Then you get the signal. Then here you make the isolation of the signal against the dangerous voltages and put it here to the microcontroller, and then herefore it goes then to the bus. Due to their design, the digital isolators have the following isolation properties. Again, safety barrier between hazardous voltages and the user. Second, separation of ground loops between spatial circuits. Third, minimization of common mode interference. And third, interference-free data transmission. Now we know optocouplers and digital isolators. When can we use which product? Broadly speaking, if you have got applications with space limitations, high channel count, high speed data rate, then you should prefer a digital isolator. If you have got, let's say, no space problems, if you have got, let's say, a low data rate, and you only have a minimum, let's say, 1 or 2 channel count, then you can tend more to go for an optocoupler. There will be an overlap here, let's say, for the data rate, but this you have to check out then what is better for you, because it can not only be judged by one requirement, you have to take all the requirements here into account and then judge between a digital isolator or an optocoupler. Both products are available at Würth Elektronik. An isolated power module. What is it? First, it is a fully integrated, here as you can see, DC-DC converter that transfers electrical energy across a galvanic barrier using a high frequency transformer here with the oscillator, where the primary and the secondary windings here are magnetically coupled but electrically separated. Where do we use an isolated power module? Here, the isolated power module is used to set up a isolated RS485. And as you can see, we have got here the optocouplers that makes a signal isolation, and the power module here is used to make the power isolation. So that here for the whole application, where you have got here the transceiver, both the power pass and also the signal pass is galvanically isolated, and disturbances cannot go to the microcontroller unit. Now we have to check what properties we have here for isolation. Here you will see that as we are speaking here of a functional isolated power module, there is no protection against electric shock. But you can use it for separation of ground loops between spatial circuits. You can use it for minimization of common mode interferences and for interference-free data transmission. Then, the well-known transformers. Everybody knows the transformers provide a galvanic isolation by transferring electrical energy between circuits here from primary to secondary through the magnetic induction, while maintaining complete electrical separation between primary and the secondary side, with this here as the isolation barrier. A well-known application for a transformer is, as we know here from the optocouplers from the previous example, here we have got now the transformer. Means the transformer is here used to make the power transmission and also then the power isolation between the primary side here and the secondary side. With a transformer, by nature, you can go here for a safety barrier between hazardous voltages and a user. Second, separation of ground loops between spatial circuits. Third, minimization of common mode interferences. And fourth, interference-free data transmission. So, what is now missing as part? The capacitor. A capacitor can realize a galvanic isolation by allowing the transfer of an AC signal or a transient signal between two circuits while blocking DC current. This is achieved because a capacitor consists of two conductive plates, first one, second one, separated by an insulation material known here as a dielectric. Where do we classically use a capacitor in terms of galvanic isolation? We use them in the primary side of a power supply. Here you have got Ln fuse, and then you have got here your Cx, the X capacitor between L and M, or between L, N, and here protective earth. What isolation properties do we have here? Again, we have here the safety barrier between hazardous voltages and the user. We have the separation of ground loops between spatial circuits, minimization of common mode interference, interference-free data transmission. A capacitor can not only be a component, it can also be, let's say, realized if you take layers of the PCB and put them in a special way overlapping over, so that you have a so-called stitching capacitor. There's also a webinar available of the stitching capacitor, and for those who are interested, here is the link. So now we know what is a galvanic isolation. We know what we can do with a galvanic isolation. We know all the buzzwords around. We know the ISOs products we have to realize a galvanic isolation. Let's try now to put this information together in one slide, and let's try to show you how you can implement all the components together in one bigger application and check this out from a pure standards point of view. As you know, we have got here the device standard IC 62368-1. The device standard is for bigger applications. That means products like a capacitor, or you have got a transformer, digital isolator, or an optocoupler will be integrated in an application, and this application will be then certified according to this standard. If we now check out how to integrate, let's say, a capacitor here, then you will see that a capacitor has no type of isolation. That means there is no information about is it functionally isolated, basic isolated, or reinforced or double isolated. So you need somehow a way to integrate it. The 62368-1 gives you here the chance that they say, okay, there is an Annex G available in the standard about components, and in this annex you can find all the informations you need to integrate the capacitor in the overall application. If you go for the transformer, then you will have the information about type of isolation. You will have a transformer with basic, reinforced, or double isolation. Here you can go to 5.4 insulation materials and requirements in the standard and take the requirements with your transformer so that you can integrate it in the overall application. So how can we implement then an optocoupler or a digital isolator? The optocoupler you can use and put it in the same direction as you go for a capacitor. There is an Annex G component, and therefore you can integrate it. But be aware, also an optocoupler has no information, if you read the standard of it, that says it is a functionally isolated, it is a reinforced, or a basic isolated. This is the, let's say, not problem, but this is the work you have to do here to understand that you have for different products that where you can build an isolation, different informations about how the isolation is quantified. You have here a type of isolation, but here you have only clearance and creepage, distance through isolation, and also the isolation test voltage. If you then go here to the digital isolator, then you can go, if you want the implementation, about this 5444 solid insulation in a semiconductor device, and 549 electric strength test. Take the information here with the digital isolator and integrate it then in the bigger standard, the IC 62368. Means with this slide here, it is possible that for all the ISO's products, you can go to the certification and know where you can find the requirements for the 62368 for each component here to make the integration possible in this bigger application based on this standard. So I hope you enjoyed what I presented here, and if you have got some questions, feel free and ask me. I will stay here for you. Thank you.
Thank you for this interesting presentation, Timo.
You're welcome.
Now we will turn our attention to the questions in the chat, and there are some interesting questions. So, first question, what is the difference between, one moment, there's
An optocoupler and a digital isolator.
Yes, and I think you mentioned something about this before, so maybe shortly.
Shortly, digital isolator is based on an LED, and the photodetector means this separation is done by a optical medium, and the digital isolator is based on a capacitor that is built up by a CMOS process.
Okay. Then the next question, why is basic isolation not enough?
A basic isolation is mostly not enough because a basic isolation is not under, let's say, under the point that if something happens, this is called the one failure analysis. That means if you have got a crack in the isolation, then you have got no real, let's say, protection against an electric shock. And this is why you always need a second, we call it, layer of protection.
Okay, thank you. Next question, can an analog signal be transmitted using an optocoupler?
Yes, this is done by the example I showed. You have got on the secondary side of a power supply, you have got the voltage divider, and this analog signal is then fed in the optocoupler and then transmitted over the isolation barrier on the primary side and fed in the controller that then is going to reduce or enlarge then the pulse width modulation. Yeah, here you can see. Thank you. Here you have it. The output voltage here, output voltage divider, and then the analog signal is going here through the diode. The diode is then lighting up, and here the signal is going to be detected, and then it's going here in the controller IC.
Okay, thank you.
You're welcome.
Next question, what data rates do you consider, low, medium, and high?
For what? If it refers to the slide where I say when to use digital isolators or optocouplers, it depends on the digital isolators or the optocouplers you're using. We have now digital isolators with 150 megabits, but if you say this is high, yes, then, but there are also data rates way up higher. Or if you say, okay, let's say 5 megabits is low, it depends on what you need. So to say low, medium, high in a real value, it refers to a certain value.
Okay. Then next question, why did Würth Elektronik certify the digital isolators according to the IEC 6747717?
This is a good question. We certify it to this standard because this standard is the most brutal, the most harsh testing standard for basic and reinforced isolation. Means you have to make a lot of destructive tests, and also during the production you have always to take some parts out of the production and make a retesting until it fails. And also this is the first standard, and for me the only standard I know that gives you the information reinforced, yes, but we guarantee for 30 years. All the other standards say, yes, you have got a reinforced or a basic isolation, but there is no connection to how long can you have this reinforced or basic isolation. And this is why we said ISO's products have to protect. We want to protect. And this is why we said we go here for the most harsh, the most brutal standard to be sure that our products don't cause any harm.
Okay. Isn't the use case of X and Y capacitors are more filters than isolators?
Yes, they use it for, let's say, the Y capacitors you use for a EMC perspective, but if you go for a, let's say, L or N to PE, then you also have to take into account there has to be an isolation. It can be basic or it can be reinforced. And therefore, you will bridge the isolation with the capacitors. And therefore, the capacitors also work as an isolation between L and PE with, let's say, reinforced. There are a lot of standards also in the 62368-1. There's a chapter that they say, okay, you have in some circuits a minimum of 2 Y capacitors you have to put in series so that you can guarantee you have your reinforced isolation.
Okay, thank you for that. Then, do you have radiation hardened variations?
To be honest, I don't know what radiation hardened variations is, but I take these questions. We can go to our optocoupler specialists and I can ask them if we have here any informations. Good question, really. I got never this question, and good to learn for me. So we will come back to the customer and get the information direct from our specialists.
Yes. Okay. With reinforced insulation, is the one insulation just as strong as with double insulation?
Yes and no. Double isolation means you have got, if this would be here our conductor 1 and this would be our conductor 2, then if I cover this here, then I can take my hand and I can get not an electric shock because one of the potentials here is blocked, is covered. But I need a second one so that in a one failure event, I will be safe. Then I put a second layer. Now I have got a double isolation. Yes, of course, but a reinforced isolation is more robust in terms of reliability, because you know this plug you put in the wall socket where you have got these 2 metal pins, and if you take this really big plastic block, this is for me the best, let's say, picture of a reinforced isolation.
Okay. Okay. Good. Then, one optocoupler can be considered as a protection device?
I don't understand clearly the question. It is a protection device. If you go to the example where we have got the power supply and then you have got the signal isolation, then it is a protection device.
Okay. All right. Then, can you explain the difference between double isolation and reinforced isolation?
This is what
I think this is
5 minutes ago.
yes, I think.
Yes.
Okay, good. Then, hi, which is the maximum frequency to use optocoupler in analog signals for insulation?
This depends on the optocoupler. We have got a broad variety of optocouplers in Würth Electronics with 1 channel, 2 channels and more. And please check the data sheet. Or if you have got a specific questions that you said, okay, I want to use this or that optocoupler, what is the max frequency? Then we can go back to our specialists and ask them this specific question, but this is a too general question.
Okay. Then the next question, digital isolators have clear standards for CMTI and EFT characterization. Then optocouplers are the reasons to keep using optocouplers.
Yes, because optocouplers you can have with 1 channel. There is no digital isolator with 1 channel, as far as I know. And also digital isolators have more their, let's say, their potential, their values. If you go for, you need more channels, you need higher frequencies, and optocouplers are more, you have got a, let's say, like you have it for the as for the switch mode power supply. This is a classic standard application for an optocoupler. So digital isolators and optocouplers are both valuable parts and both have their special applications. There is an overlap as I showed, but you need both of them. You cannot only go for one of them.
Okay. Then the next question, why are the isolated power modules not suitable for electrical safety? On your slide, this application had a red X.
Yes, because our isolated power modules are only functional isolated. That means the potentials are shifted or have got a distance somehow, but there is no real isolation that can withstand a hazardous voltage. And this is why we clearly say here, you cannot use it. You are not allowed to use it, because there is a little bit of a misunderstanding. You can have 4,000 volts between the input and the output of a power module, but that does not mean that you have got a basic isolation. And this is why I clearly put this there, this red X. You're not allowed. There is no safety.
Okay. And then I would say the last question, when using differential pairs, which kind of isolation is best suited?
When using differential pairs, which kind of isolation is best suited? Is this a wire that is paired, or sorry, it would be the best if, please, dear customer, rephrase this question, or if you have got a schematic or more information, please come back to us and then we will answer it. No problem.
Okay. Thank you, Timur. Yeah, so now we are finished with our webinar. If there are any questions left, of course, we will answer them afterwards via email. Yeah, thank you for your attention, and I hope you enjoyed the webinar. Thank you, Timur, for your time.
Thank you.
We wish you a good day. Have a nice day. Goodbye.
Bye.